Okay, we have talked about stress. Now we will talk about strain. Now, what is strain and different kinds of strain? Okay, strain. Suppose there is a deformation that is happening. This bar is fixed here. Okay, sorry for the line. This is pulled with force P. Now, due to the deformation, this will elongate. This change in length, this change in length, this change in length is the measure of deformation of the bar. But how to measure it so as to relatively compare two or three bars irrespective of their cross section areas? So we have to divide it with the original length. We have to compare with the original length. If the original length is L, the original length is L, then change in length per unit length, unit original length is our strain. Uh, we can quantify the strain as uh, this uh, E equals to change in length del L by L. Let us take an example. This also we know that this is unitless. Unitless. Let us take an example of a bar. Okay, rectangular bar. This force P is applied here. And this has length L, breadth B, height H. And then longitudinal strain is change in length, or we define the term longitudinal, which is parallel to direction of force applied. Change in length by original length. Let us longitudinal strain. Okay, these all are normal strains because all the strains are perpendicular to exactly perpendicular or parallel to this force P applied. Lateral strain. Lateral strain is the strain of dimensions other than longitudinal strain. Uh, Del B by B minus del S by H. It is very conceivable that if length increases, the breadth and height must decrease. So negative sign is presented there. Third kind of strain is volumetric strain. Volumetric strain is change in volume. We know that there is change in volume per unit volume. This is quantified as volumetric strain. We know that change in volume is final volume or after deformation minus original volume. After deformation it will have L minus L plus del L, B minus del B, H minus del H, minus length, breadth, height. This will be the quantification of del V. Original volume is LVH. So this is how volumetric strain is measured. These all are these two are longitudinal strain. Let us talk about shear strain. Okay, shear strain. Suppose there is a force P applied on a bar which is fixed like this. P, it will undergo the deformation like this. Sorry, my end is not so accurate. So delta, this is change in length, this is B, the original length will be L. So shear strain can be quantified in terms of as this sign, not R. uh, this is change in length per unit height, or simply we can say height. Okay, so this is in terms of geometry, this is tan theta. This is how shear strain is developed. Now let us talk about the Poisson's ratio. Okay, what is Poisson's ratio? Mm, for, it is nothing but the ratio of lateral strain up to longitudinal strain. Uh, Lateral strain minus lateral strain upon longitudinal strain, or simply minus of del b by b, minus of del b by b and del L by L. So this is our Poisson's ratio. Okay, we can simplify easily, this easily. Now, volumetric strain. We have talked about volumetric strain. Uh, okay, I think this is all about stress. We will talk more about Hooke's law and other parts later.